everyone, it's me, Dr. V, and it's time for another chemistry webcast. In this webcast, we're going to be talking about the molarity formula. So what I'd like to do in this webcast is introduce the molarity formula, which is really important, and talk about ways to rearrange it, which makes the problem-solving side of things a little bit easier, and then go through two molarity problems with you. The molarity formula is defined as the moles of solute divided by the volume of the solution in liters. I do want to point out, notice we're using a capital M to represent molarity. You're going to see that a lot. It's got to be a capital M, not a lowercase m. I also want to remind you that when we talk about the volume of the solution, we're talking about the whole volume of the entire solution, not just the volume of the solvent. I do want to point out that the molarity formula is included on the AP Chem reference sheet. It's in the gases, liquid solutions section of the formula sheet. And that's great. It's nice to know it's there. But honestly, you're going to use it so much that you really need to memorize it, folks. And you shouldn't be looking it up every time. You really just want to make sure you know it. Moles over liters. Now, there are some rearrangements we can do with the molarity formula that just makes our life easier depending on what you're solving for. We often will rearrange it to solve for moles. So the moles of the solute would be the molarity of the solution times the volume of the solution in liters. This shows up in a lot of different situations. We can also rearrange it to solve for volume. All right, so the volume of the solution that we make would be the moles of the solution divided by the molarity that we're trying to get to. Now, in lab, we typically measure the mass of the solute, and we know that mass and moles, of course, are related, right? We know the moles are the grams divided by the molar mass. So we can actually take this and substitute this expression for moles right into our molarity formula, and that brings us to a different version of the molarity formula. Grams of the solute divided by the molar mass, all of this in the numerator, divided by the volume of the solution in liters. Now, this equation is really handy, again, because we're usually working with the mass of the solute, and so putting that into the molarity formula just makes it easier. And then we can rearrange this equation to solve for the mass of the solute. So the molarity of the solution times the volume of the solution in liters times the molar mass of the solute would give us the mass of the solute in the solution. And that's just a really handy rearrangement. Pro tips. What are some things you should watch out for when you're doing these problems? Pay attention to your units. We often measure volumes of solutions in milliliters, but it needs to be in liters when we're doing the molarity calculation. So remember, there are 1,000 milliliters in a liter. And I know you're probably thinking, why is she saying this? I know this. Yeah. Do you know how many times students forget to do this? The other common thing would be grams versus milligrams. If you measured the mass of your solute in milligrams, you would need to convert it into grams to then go find the moles. Again, these are very common mistakes that students make, especially if they're working quickly or they're feeling under pressure, maybe in a test setting. You want to pay attention to that. In general, though, when we're thinking about solving these problems, list what you know. What are you given? What's the solute? What volume do you have? What molarity are you going for? What are you solving for in this problem? So you can rearrange the problem correctly. And then you can set it up. You want to rearrange your equation, and then you can go ahead and substitute and evaluate to get your answer. AP Chemistry students need to be able to work with molarity problems and the molarity formula and be very, very comfortable with it. You really can't practice this too much. So let's do the first problem together. 41.52 grams of potassium nitrate, KNO3, are dissolved in water, and the solution is brought to a final volume of 525.0 milliliters. Calculate the molarity of the solution. Let's think about what we need to do here. We want to find molarity. Now, we do know that we have the mass of the solute, the potassium nitrate, so I want to use the version of the molarity formula that's already got that substituted in. You could, of course, calculate the moles of the solute and then put it in. I like to do it all together, but in the end, it all comes out the same. So we have potassium nitrate. We are going to need its molar mass, which is 101.10 grams per mole. I recommend with molar masses, always keep at least 2 digits after the decimal place or whatever precision you have on the periodic table that you're using. And we also know the final volume of the total solution is 525.0 milliliters. But here's one of the places where we need to be careful. That's in milliliters, but we need liters to do the molarity formula. So we have to divide by 1,000. So my volume of the solution in liters is 0.5250 liters. And I'm not dropping that zero. That needs to be there. Think about your sig fig rules. So at this point, we can substitute everything in. We get 41.52 divided by 101.10, and then we have to take that and divide it by 0.5250, and we get an answer of 0.7823 molar for our molarity of the solution. I do need to report the answer with 4 sig figs. I knew my mass of solute with 4 sig figs. I know my molar mass. More precision than that. That shouldn't be what limits my answer. And I have 4 sig figs in that volume. So I do need to report this molarity with 4 sig figs. All right, let's do another problem. A student needs to prepare 350 milliliters of a 0.75 molar solution of sodium chlorite, which has the formula NaClO2. What mass of sodium chlorite in grams are needed? These are very common questions, things that we should be able to do. Going back to our molarity formula, and again, I'm using the version where I've substituted in the grams over the molar mass version of the equation, but I need to find the grams of the solute. So you remember, we know how to rearrange this to calculate the grams of the solute, which is the sodium chlorite. The molarity times the volume of the solution in liters times the molar mass of sodium chlorite. So I know that my molarity is 0.75 molar, and I'm noticing that there are 2 sig figs in that value. The volume of the solution we're given as 350 milliliters, but again, we have to remember to convert that into liters. That's 0.35 liters, and that has 2 sig figs. And we also know the molar mass of NaClO2 has a molar mass of 90.44 grams per 1 mole. So we have all the information we need. We can substitute that into our equation. So we know the molarity, we know the volume, we know the molar mass. We multiply that out and we get an answer. On our calculator, it says 23.7405 grams. But whoa, wait a minute here, folks. We can only report our answer to 2 sig figs. The molarity had 2 sig figs. The volume had 2 sig figs. I can only report my answer to 2 sig figs. So I do need to report my final answer as 24 grams. Molarity problems are really manageable. They're very doable. You do want to make sure you practice with them enough until you're feeling very confident with them and you can do them reliably and pretty quickly. In terms of just wrapping up final thoughts, make sure you read the question carefully. What do you know? What are you given? Check for your molar mass. Make sure you've calculated that correctly. Pay attention to the volume units, milliliters versus liters. Make sure you know what you're solving for so that you can rearrange the equation correctly. You do want to make sure when you're doing these problems that you're showing enough work to support your answer, not just answers appearing out of nowhere. And it's also important that you remember to report your answer with the appropriate number of sig figs. I hope you found this helpful. Subscribe to my channel so you get all my latest updates as you go through your AP Chemistry journey. Keep studying chemistry every day. That's the key to success.